Hi, welcome to Mathematics with Tom. This is Tom, and today we're going to talk about conditional probability. Conditional probability. And we're going to take a look at, well, let me explain what it is first. Well, we'll define it as we go. Let's do it that way. So here's what we're going to do. We have a box. It could be a jar or a bag, doesn't matter, but we'll call it a box. A box has, let's see, how about we'll have two green marbles. So I'm going to use a capital G from now on for green. 2 green and 3 yellow, and we'll use a Y for yellow marbles. Oops. We're going to find the following probabilities. Find the probabilities. Probabilities. Find the probabilities. Okay, so here's what we're going to find. We are going to find the following ones. One is we're going to find the probability of selecting a green marble. Okay. 2, we're going to find the probability of selecting a yellow marble, and then provided that a green was selected. Now, this bar right here, this little bar, is read as provided that. Or you might also hear it written or see it written as given that. And then it means that the G has happened. You've already selected a G. What's the probability now of selecting a Y? Okay, and then the third probability that we're going to find today is the probability of selecting a green and a yellow. And that has to be in that order. So the order matters, in that order. Now, I think I'd like to develop a motivation for this. So let's do it this way. To develop our motivation, let's make a little table. So we're going to make a table to keep track of this. So make a table. Make a table to see the outcomes. Okay. Now think about this for a moment. If I had I'm going to come down into this corner here. If I had a box, this, and I have 5 marbles in it, like that. 1, 2, 3, 4, 5 marbles. Now 2 of those are green marbles. So just a sec, I'm going to sneeze. Oh, excuse me. So 2 of those are green marbles. And 3 of these are yellow marbles. But to keep track of the fact that we actually have this many marbles, I'm going to call this the greens. You might have green 1 and green 2. And then instead of doing yellow 1, yellow 2, and yellow 3, let's call it Y3, 4, and 5. So now if I want to if I use the number 1 or the number 2, that's talking about the green marbles. And if I use the numbers 3, 4, 5, that would be talking about the 3 yellow marbles. So let's do this. Let's make our table, and we'll do it this way. We'll do that as first draw, and second draw. And I should add one more thing. So find the following probabilities. And what we're going to do is there's going to be without replacement. Without replacement. In other words, once you pull the marble out, you don't put it back in and then draw. You take it out, leave it out, then take your second draw. Or another way of thinking of that would be is to be like reaching in with two hands and checking the left hand and then the right hand and always doing it in that order. So second draw. So first, what we could do on the first draw is we could get the 1, the one of the green ones, the 2, that's the other green one, the 3, that's the yellow, 4 or 5, those are the yellows. Okay, now let's do it this way. I could get, though, on the second draw, though, I could get a 1, a 2, 3, 4, or 5. Now, let's say on my first draw, so let's work on first draw 1. I can't, since the marble isn't going back in the bag, since it's not going back in the bag, there is no first draw 1, second draw 1. But I can have this. I can have a 1, 2, meaning I reach in, I draw the first green one, and then I reach in again, and I draw the second green one. So we're going to record what happens here as an ordered pair. So the first number will represent the first draw, and then the second draw will always be the second number. So we'll use that ordered pair format. So my next draw would be like this: 1, 3, meaning I got a green one and then a yellow one, and then I have 1, 4, and meaning a green one and then a yellow one, and again a green one and the yellow number 5. Now let's try it again. This time I first get a 2. Well, but then I could get the 1, the other green one. Now remember, I can't have doubles. Can't get the green one twice because it was already pulled out on the first draw. But I could have a 2, 3. I could have a 2, 4. And I could have a 2, 5. Remember, 2, 5 means that I first drew the green 2 and then I drew the yellow 5. So then let's try it again. What else could happen? Well, I could reach in and I could pull out the 3. The 3, that was one of the yellow one, and then I could reach in and grab the green one. Or I could grab that yellow 3, or I could grab the green 2. Now remember, I can't have the doubles because I can't draw it. I can't draw the same marble twice because it's been removed from the bag. And then I could draw yellow 3 followed by yellow 4, or I could draw yellow 3 followed by yellow 5. Then let's continue this out 2 more lines. So here we go. I could draw yellow 4 and then green 1. I could draw yellow 4, green 2. I could draw yellow 4, yellow 3. I can't do 4, 4, but we could have yellow 4, yellow 5. And let's do one more of these. So let's take a look at this. I could have yellow 5, green 1. I could have yellow 5, green 2. We could have yellow 5, yellow 3, yellow 5, yellow 4, and of course you can't have yellow 5, yellow 5. So now we're to the position where we can start finding these probabilities. And I'm going to do these in some different colors because we're going to kind of build up part of this and then we're going to take it away. So the first thing to notice is the size of the sample space. We'll call that n. So sample space n, it's not 25 because there's these pieces here. There's 1, 2, 3, 4. Those 5 are not in there, so the size of our sample space is 20. Now, let's take a look and find out what is the probability of just drawing a green marble. So obviously, it's just you're only getting one draw. So the probability of getting a green marble, and let me put it this way, green marble on first draw. So the probability of getting a green on the first draw, and this number 2 is on second draw. Now, so the probability of a green on the first draw, that can happen. Well, I'm going to use this, maybe this kind of this color. So a green, look at, here's all the ways I could have a green on the first draw. All of this space. And notice if we count this up, there's eight different outcomes out of 20. And so the green on the first draw, I could say the probability is 8 out of 20. Okay, now let's do this again. On the second draw, now this is a little unique. This says on the second draw, what's the probability it's yellow given that you've already drawn a green? You've already drawn a green. Well, that changes the story a little bit. Let's see how. Changes it to orange probably. Well, notice that means that our sample space now isn't the entire sample space. It's this blue. The blue is my sample space because those are the ones that I first drew a green. Then the marbles where I drew a yellow on the second draw, that restricts it down to this inner rectangle, and maybe I'll do that in this light pink, this rectangle here. So what I've done now is I've restricted the number of marbles that I'm looking, or I've restricted my sample space. So on the second one, the probability of drawing a yellow, given that it was green, is now there was eight outcomes in the sample space and 6 of which were a yellow on the second draw. Because the first two, the 1, 2 or the 2, 1, means you got a green on the second draw. So we wanted any that had a 3, 4, or 5 in the second position. Okay, the last one we want is this one, and it is the probability of a green and a yellow in that order, though, in that order. Well, so to have first a green and then a yellow in that order, well, we're back down to the same pink box. There's only those 6 out of the entire 20. And I'll highlight that again to bring attention to that box. It's this box right here. Again, these 6 are the only 6 where you had that order of one and then the other. So that was the probability of a green given a yellow. Now, I'm going to show you there's a relationship between these. There is a relationship. And if you play around with these numbers, let's play around with them. Let's write them this way. That the 6 out of 20, I want to find a product. I'm going to organize these so I get a product. How about 6? How about 8 out of 20? And then times my 6 out of 8. Okay, so look at what we have. If I rewrite these now, the 6 out of 20 was the probability of getting a green and yellow in order. And that was equal to the 8 out of 20. Well, that was the probability that you first do a green, times, and the next one was the probability of selecting a yellow on the second draw, but that yellow was only of interest if you had already drawn a green, which is what we had done. Here is the first draw. Oops, that's first, not first draw. And then here is our second draw, and it was only dependent upon what had already had to happen. So, and by doing that, notice that what happens is as soon as you restrict what your outcomes are going to be, then we have what are called dependent events. dependent events. And the easiest way to think of dependent events are, because the second one was dependent upon what happened on the first draw. And then the numbers changed. It wasn't as easy as you might have thought. So dependent events are events where what has happened, or what happened, affects the probability of what can happen. Of what can happen. So that is where you get that's the motivation for the formula and the idea behind conditional probability. In our next video, we're going to take another look at an example of conditional probability and what happens when the dependent events become independent events. Hope that